Today we are going to discuss on a very important topic which is about effective solution to take care of leakages in hydrogen carrying pipeline. Now question rises that why leak prevention matters. As you must be knowing, hydrogen is the smallest and lightest molecule, making it highly prone to leakages through even microscopic gap in pipeline system. Preventing hydrogen leaks is critical not only for safety with hydrogen's wide flammability range, as you all know, but also for operational efficiency and regulatory compliance. We can say that these talks outlines proven material, sealing, monitoring, and maintenance approach to ensure reliable hydrogen pipeline containment. Now, our coming to our next slide, which is about a very important aspect of joint sealing and materials overview. It's a very important area. So let's start with the pipeline joint and materials. For a threaded joint, a specialized a thread sealant, especially anaerobic types, are essential as they fill even the teeniest gap. For flames or valve connections, reinforced graphite-based gaskets are highly effective against hydrogen escape. Selecting austenitic stainless steel like 316L for pipes and reinforcement offers strong resistance to hydrogen permeation and corrosion, forming the foundation of a robust containment strategy. Now, coming to our anaerobic thread sealant for threaded joint. How do anaerobic thread sealant work? These sealant cure when they are applied between metal threads and deprived of oxygen, forming a tight thermoset plastic seal. And products like LOC TITE 567 or 570 can withstand pressure up to 31 bar, some even exceeding 1000 bar, and handle temperature above 200 degrees centigrade very easily. So this is critical as threaded joint are frequent leak initiation points, especially under vibration or pressure cycling. Now coming to the key advantages of anaerobic sealant. The key advantages are they create a complete, absolute complete surface seal, preventing microscopic hydrogen leaks, resist vibration, pressure and thermal changes, and allow for easy maintenance by enabling clean assembly and disassembly. Now, chemical compatibility with hydrogen is confirmed by standards such as KIWA. Remember, even minor leak in hydrogen system can be hazardous. So using proven sealant is very essential. We must not overlook in any deviation in these sealants. Now coming to our graphite based gaskets for flange and valves, for flange and the valve joints also, graphite based gaskets like reinforced Sigraflex provide a reliable seal, and this is one of the very popular item. These gaskets combine flexible graphite with stainless steel or nickel reinforcement, ensuring both chemical resistance and mechanical strength across a temperature range from 200 degrees centigrade to over 450 degrees centigrade, and handling full vacuum to very high pressure. Their deformability means they conform tightly to irregular flame surfaces, blocking hydrogen migration even over long service life. Now coming to the austenitic stainless steel 316L material matters, especially under hydrogen duty. Austenitic stainless steel, especially 316L, are industry standard because their nickel and chromium content resist hydrogen embrittlement and permeation. The low carbon, and that is L grade, further resist weld corrosion, maintaining ductility and fatigue strength, essential for safety critical applications, recommended for any hydrogen pipeline environment. Now coming to detection and monitoring leak detection, which is also very critical lines of defense. Now place hydrogen a specific detector at key locations such as valves, flange and storage tanks. Integrating this sensor with a real-time monitoring, often IoT based, enable prompt alert and can automatically activate shutdowns or emergency ventilation, because that is the activity which is most important, minimizing risk from undetected leaks and ensuring shift swift very swift mitigations. So this is one of the most essential part. Now coming to preventive measures and maintenance, which is also no less. So no material or seal lasts forever, as we all know. So regular inspection and preventive maintenance are vital. Schedule hydrostatic or helium leak test at all joint and fitting to catch leak early is must. Leveraging predictive maintenance with data analytics or digital twin further reduces the chance of slow, undetected leak and preempts failures because before they escalate to a very critical level. Now coming to the additional best practices beyond hardware, system design and training are the key. Wherever possible, use double containment or secondary barriers in sensitive area to safety channel any potential hydrogen leaks. So ensure all operational staffs are trained in both leak detection and emergency response through regular drills. This readiness can make the difference in rapid, effective mitigation if a leak event occur. So, as we come across this, both components are very important. Now, in conclusion, systematic lead prevention to summarize a systematic approach combining advanced sealant, number one, robust gasket material, hydrogen compatible seals, comprehensive detection, and predictive maintenance ensure long term pipeline safety and reliability. As just now we have discussed in the preceding slides, continuous staff training and smart design further strengthen hydrogen containment, and preventing leak is not a singular act but a disciplined one. Ongoing processes for every hydrogen pipeline installation is must.